since the pressure is more against the bottom, what's to prevent that dam from scooting downstream? Especially when water seeps in here and you get these like little pebbles in here, like ball bearings. Why couldn't that whole dam start to come downstream? It could do that, couldn't it? But you can stop it. You know what you can do? You can put a heavy weight on the top. Tons of lead. You could squash it right down, and that heavy weight would scrunch the dam right in there, and it would be held secure. But there's a better way. You don't need the big chunk of lead. You know what you do? You design your dam like this. Why? Now the water's going to push like this. Which brings us up to a little rule. A fluid will always push in all directions against an object, but all those directions will conspire to give a perpendicular force, right angles. And so the weight of that water would hold that dam right against the bottom, just as a great big heavy lead weight on the top would. So pressure pushes in all directions, but the force of that pressure always turns out to be perpendicular to the surface upon which it acts. You know that's true because if you take a bucket and you put it in the water and you punch some holes in, but no matter where you put the holes, when you put this down there, the water will spurt in. If the hole's here and you're dunking under the water, it'll spurt in that way. If the hole's on the bottom, it'll spurt straight out. Put an angle like that, it'll spurt like that. It will always spurt perpendicular to the surface because it acts in all directions. Water pressure, interesting stuff.